In this video, we will be looking at how to find out derivatives using the first principles. Okay, previously we have derived how to come at the first principles formula for finding out derivatives. Now let us take an example of, say, a function fx which equals to x square. So now, I need to first of all focus on what would be the difference quotient for this function. Now the difference quotient essentially is the difference between the functional level, so fx naught plus change in x minus fx naught. So basically what we are looking at is the function at a new point x naught plus change in x and the previous point x naught upon the change in x. So that's my difference quotient, and the derivative, as we have learned previously, is essentially the difference quotient as the limit of change in x goes to 0. The change in x becomes very minute, as 0. So now just putting in our values of x naught plus change in x, basically x square is our function. So now my new function becomes x naught plus change in x square, okay, because my new point is x naught. So fx naught plus change in x equals to x naught plus change in x whole square, okay, and x naught square upon change in x. Now here I have a plus b whole square, a plus b whole square. Can I make use of some calculus out here and just open it up? So I get x naught plus change in x whole square plus 2 x naught into change in x minus x naught that I have from the previous upon change in x. So now this and this would cancel out with each other. So what remains is essentially the central terms change in x whole square plus 2x naught into change in x upon change in x. Now next what will happen is that you can take out change in x common from the numerator, right? So my numerator is this, okay, 2x naught into change in x plus change in x whole square upon change in x. And once I take out change in x common, what remains is 2x naught plus change in x, okay. This cancels out with each other. So 2x naught plus change in x would remain, okay. Now I need to look at the limit, okay, limit as change in x goes to 0. Now as change in x goes to 0, change in f upon change in x equals to, this thing is almost going to 0, so it's just 2x naught. Diagrammatically, if I want to look at it, what will it look like?